Can you memorize physics? Using this method, I've helped thousands boost scores from 30 to 70 points on the college entrance exam. Next, I'll give step-by-step solutions for each problem type. No need to think. When you see a problem, follow my steps. If you don't believe me, watch me solve real exam questions in 5 minutes. Save and follow for more simplified steps. Today's topic is piston cylinder problems in thermodynamics. The basic approach is finding the pressure, volume, and temperature of the gas at critical states. Then for the pressure, we need to analyze the forces acting on the piston to determine it. Finally, we can set up the equation V1 over T1 equals P2V2 over T2 to solve the problem. Remember this three-step problem-solving approach. Now, let's take a sample question as an example. Let's look at this problem. A piston with mass m seals this ideal gas, and the height from the bottom is h1. Now, if we place a block with mass m on top, the block will press the piston down, moving it to a height of h2. Now, the question is, what is the value of h2? Let's use the three-step approach to solve this. The most important part is to determine the pressure, P, of the enclosed gas in its different states. Let's first find the pressure, P, in its initial state. To do that, we need to analyze the forces acting on the piston in its initial state. Initially, the piston is pulled by its weight, mg, and atmospheric pressure, P0s. The gas pressure provides an upward force, PES. Thus, PES equals P0s plus mg. In this way, P1 becomes a known value. Alright, I'll write it here. At the same time, the initial volume V is very simple. It's just H1 multiplied by S. Since the temperature hasn't changed, we can ignore it for now. After pressing it all the way down, what is the pressure then? We should analyze the forces acting on the piston at that point. Let's consider the piston and the mass as a whole. As a whole, they are subjected to two weights, the large mass m and the small mass m. And there's also a downward atmospheric pressure, P0s. Then there's an upward force, which is the gas pressure at this point, P2s. Similarly, we can get that P2s equals P0s plus mg. In this way, we can find the value of P2. Good, P2 is a known value. H2 is what we need to find. As for the temperature, since it hasn't changed, we can ignore it for now. Finally, we can set up this equation, PV over T, which means PV is this value. Divided by T, since T hasn't changed, we won't write it, equals P2V2 over T2. Alright, in this way, since all of these are known values, we can directly solve for H2. This is the basic approach to solving all piston problems. Next, I'll add a few key points of knowledge that are needed for piston problems. First of all, we must use Kelvin, K, as the unit for temperature, not Celsius. The conversion between Kelvin and Celsius is a difference of 273, and here there's a little joke. So, there's a joke about someone who goes into a cold storage room, and the temperature inside is minus 273 degrees Celsius. Everyone is concerned about whether he's okay, but he says he's okay. Alright, that joke was a bit too cold. Let's move on to the second point. When the problem states that the cylinder is thermally conductive, it means that its temperature will be the same as the external environment. Whatever the outside temperature is, that's what the cylinder's temperature will be. If the cylinder is adiabatic, it means that the internal temperature is not synchronized with the outside. The internal temperature can change. Thirdly, we only need to analyze the forces acting on the piston in a steady state. We completely ignore the intermediate processes. For example, if you want to know the pressure of the gas in the first state, what should you do? Then you analyze the forces acting on the piston at the very beginning. Alright, then if I want to know the gas pressure in the second state, what should I do? Then you analyze the forces acting on the piston in the second state. As for what happens in between, how it changes from here to there, I don't care about any of that. I just need to look at the positions directly. And finally, when you're doing the force analysis, make sure you don't forget about atmospheric pressure. A lot of students tend to overlook this. Just a reminder. Next, let's look at a real question from the college entrance exam. As shown in the figure, this is a liquid tension dynamometer with a volume of 9.9 liters. The cylinder conducts heat well and is at the same temperature as the external environment. It is sealed by a piston with a mass of this much and a cross-sectional area of this much, enclosing an ideal gas. Ignore all friction. At the lower end of the piston, a metal wire with a mass of 10 grams is suspended by a thin string. The piston is currently at position A. Next, the metal wire is immersed into a liquid to be tested, and then the cylinder is slowly lifted. As a result, the metal wire is also pulled out, and at this point, the position of the piston changes to B. It is known that the distance h between points A and B is 10 centimeters. Also, the external atmospheric pressure and the ambient temperature remain constant, which means the temperature of the gas also remains unchanged. Now let's solve the first question. To find the pressure of the gas in the cylinder when the piston is at position 1, as we discussed in the previous three-step approach, if you want to determine the gas pressure, you should analyze the forces acting on the piston. Alright, let's go back to what we just discussed. At this point, let's analyze the forces acting on the piston. For the first question, we should consider the piston and the metal wire together as a single system. At this moment, the entire system is subjected to a downward force, which is the combined weight of the two objects, m1 plus m times g. There is also a downward force, which is the PS that we need to find. In addition, there is an upward force from atmospheric pressure. Don't forget P0S. In this way, we can set up the equation. P0S equals PES plus the weight of M1 plus M2. Alright, with this, we can directly solve for P1. Since this is a known value, I won't calculate it here. Now let's look at the second question. Of course, when the piston is at position B, now the piston is at position B, the question is, what is the magnitude of the force F that the liquid exerts on the metal wire? At this point, we notice that for this enclosed gas, let's first determine its pressure, P. Let's find the pressure of this enclosed body. The initial pressure of this enclosed system is just the P1 we calculated earlier. As for its volume, the problem stated at the very beginning that it equals V0, which is a known value. The temperature hasn't changed, so we won't write it. Later, its pressure, which is what we need to find, is P2. We need to solve for P2. So, what is its volume later on? It should be V0 plus this additional section. As for that additional volume, it should be the distance h, multiplied by the cross-sectional area S of the piston. In this way, we can set up the PV over T equation. Following the three-step method, we know that P and V0 are all known values, and since T hasn't changed, we don't need to write it. So it equals P2 times V2. For P2 V2, that's V0 plus H times S. Remember to use SI units when you substitute the values. I won't do the calculation here, but this way you can directly solve for P2. Okay, now P2 is a known value, but in the end what we need to find is the tension in the metal wire. You see, we already know. We can use the force to find the pressure, and now that we know the pressure, of course, we can also work backwards to find the force. Now, let's consider the piston and the metal wire as a whole, and analyze the forces acting on the entire system. The total force should include a downward force, which is the combined weight of the two. Then, there is also a downward force, which is P2 times S at this moment. There is also an upward force from the gas, which is P0 times S. Don't forget, the problem clearly states that the liquid exerts a tension F on the metal wire. If there is such a tension, then there should be a downward force F acting on it. With this, we can set up the equation. P0S equals P2S plus M1 plus M2 times G, and then add F. All of these values are known, so F can be solved for. I won't do the calculations here. You can work them out yourselves and write your answers in the comments. I'll let you know whether they're correct or not. Based on this, we can see that even for college entrance exam questions, we only need to follow 3 steps to solve any piston-related problem. That's all for today's content. Remember to save this video so you can review it anytime if you forget. If you understood everything, share it with your best friend so you can all improve together. I'm Teacher K from Minimalist Physics, and next time I'll continue to bring you more ways to boost your scores without having to think too hard.